Okay, we're going to get started. My name is Mike Houston. I'm with Vitria. We're going to demonstrate our IoT analytics platform today with my colleague Hanlon. And I'm just going to tee up the demo a little bit to get us started, and then we'll go through our active demonstration. We're hoping to have some questions at the end, and we're also going to be giving away an iPad Air 2. As some of you may know from the email we sent out, we're going to pass around a little fishbowl for that, and everyone who stays to the end of the demo has an opportunity. So first, just very briefly about Vitria. It's a company that's been around 20 years. Our original heritage is an enterprise platform company focused on application integration and business process. And we've built off that, now working on a platform for IoT analytics, and we've put that all together into a single new platform, which is what we're showing to you today. We're going to go through the live demonstration here in a minute, but just to give you a high-level orientation about the platform, there's really three pieces at a very high level that count. There's data at the bottom of the picture you see there in a couple of different approaches. Then there's also, we have what we call our temporal analytics engine that integrates all types of analytics along with the action and business process that I talked about a minute ago. And then what we call our command center, or the visualization layer. So there's three key focuses in terms of the platform which we'll be talking about. And then as Hanlon steps through the demo, she's going to be stepping through the workflow process of how our SaaS solution works, which is the first public showing here today. It's a cloud-based solution to do analytics for IoT. And there's a thing definition service that's part of the core platform that's going to be shown. There's also data services, the core analytics services that are the most differentiating part of the platform, and then also the visualization services. What's key is that all four of those work together, and that makes our platform very unique from other things you might see out there on the market. So again, thanks for coming today, and I'll turn it over to Hanlon.
All right, thanks. Thanks, Mike. Thanks, everyone. So today, I'm going to demonstrate a use case from Smart Grid Network. So basically, we are monitoring the meters in the network, assuming I'm operating a power grid network for California. So I'm interested to understand how my power has been consumed. I'm also interested to understand how I can provide adequate supply without overcapacity to support my customers. At the same time, how I can ensure my power grid network operates at the best performance level without leakage in the middle. So with so many different kind of use cases, today, for this demo purpose, we are simplifying our data set, our scale of network, just to demonstrate how demand and supply works in this simple use case. Okay, now let me switch to, okay. So before we explore this, let me explain a bit on the setting. I started the solution about 10 minutes ago. That's why you see the timestamp here is running right now. So I will start with the left panel at network level at different use cases. As you can see, there are many key indicators I have configured for my analytics solution. For this demo, I will only focus on the first one, which is a consumption level. And the second widget here provides you a summary at the total key indicators I have configured for my network. Three of them are red. The status is in red status, then one in green. Rest of two are gray, which means there is no judgment or status associated with those indicators. So the bottom two widgets actually provide you kind of a report on your data. How many liters currently in my memory under processing, then how freshness your data is, whether the meter data comes in right now or meter data is from yesterday. So we feel the data quality report is extremely critical for any analytics solution. That's why we provide these two widgets here. As you can see in the middle panel on the top, we provide a time series data that covers the current, which is inside the memory we are processing, we are analyzing for you. Those two time buckets here in purple color. After we process in real time, we actually move the data to the historical database. That's why you see all these blue slots here. The gray three slots are the project value in the near future. We have some basic machine or algorithm built into the system. In this demo, a very simple use case, we just enable linear regression to tell you what may happen in the future based on the trending line we have applied to your time series data. As we can see that you can explore any your meter network situation right now at any this time slot. For me, I choose current. You can see at the transformer level because this meter network covers my entire California network. So I aggregate those meters into transformer level. You can see, for example, let's choose this group, right? This group has 100 transformers. Then if I like to see individual transformer, actually I can right-click, then disable the group maker, then I will get individual transformer level. So you can see the status associated with individual transformer. Some of them are green, that means they operate at the right level. Some of them are red, that means their supply is below the demand. Let's click this one, this specific transformer in Santa Barbara. Okay, before I click that one, if you just mouse over it, this gives you at population level. At this case, it's transformer level, how the KPI has been judged, how we compute. Then this is what you have get for this specific transformer. If you click this transformer, first of all, you'll see the blue color indicate that's the one you are analyzing right now. And the bottom actually provides you all the meters in this transformer. So you can see the data is uploading in real time. At any of the time, you can see there's at meter level, you also see the time series data, what we're processing right now, what we have in the near future. You probably already see some blank spot here. That means we didn't receive the data from this meter. That's why you didn't see any of data at specific time. We compare the current value from the previous one, from our time series data. We also use the projection to say, okay, what may happen on this meter at the next reporting period. For this demo purpose, we actually reduce the data reporting period. Typically, smart meter will report data every 15 minutes, but just for this demo, we reduce that to every single minute. That's the reason you see the time series on the top actually is changing in real time. So that's how we do it. So from the right panel, you see the notification that is alert generated by our system based on the KPI result, based on the judgment you have configured, and how you want your notification to be scheduled. Then we have a reference data that can be anything for a specific meter. For example, if you have a customer information you like to associate with that meter, you click that meter, you actually get all the information. In this case, we have a months in service data associated with individual meter. We also have the weather data about each individual meter. So this is based on the transformer ID. We aggregate the entire network. You can look at this from different chart based on your own personal preference. At the same time, we enable multiple dimensions or populations that you can do. For example, you can see your meter network based on the manufacturers, or you can actually see, there's one feature I really like, it's based on your KPI judgment. For example, for my network, I have 3,000 meters for now. I only interested in those who are not operating in the right status. How I can do that? Okay, this is how you do this. You choose the KPI judgment, so the entire meter network will be judged based on the good, red, or fair. Then you can specifically look at all the meters that are running in the wrong status. Then for those anomalies, you can see, okay, this is what's happening in my network. So this summary dashboard gives you some tempo view of your meter network based on the analytics outcome we have a compute in our memory. As you can see, we enable those historical data as well that allows our user to study the data further to develop their own algorithm, maybe for predictive, maybe for other variable importance study. So that's why we introduced a second page right after this. We call it diagnostic analytics. So that allows the entire historical data we have saved from our base accessed by our individual users. The top three widget you can see is the same from the summary dashboard, which you can choose specific KPIs you configured. You can choose either one of those time slot window, or you can choose all. It's just based on your own personal preference. You can also choose based on the status. Let me pause for a while so we can avoid constant data update, but we can really study the entire historic data for now. On the right bottom side, you'll see this variable importance. So why do we introduce this widget here? Here is our machine learning random forest algorithm running across entire historic data we have in the database. What we do is we try to understand what are the key factors that contribute my status the most. So based on this learning, we can see, okay, the transformer weather, that means, okay, the only reason you see this transformer weather because we got this data from reference data. So it based on the transformer. So weather is the most important factor that contributes your consumption at this time. Then you also have the data transformer months in service that may link into some other use cases. For example, whether you have a leakages associated with transformers in case your transformer months in service is over the certain threshold. So this is the entire raw data we have captured from the historical database. So let me see this. Okay, since weather is the most important thing, let's see. I will choose the first dimension as the transformer weather. Then I also like to change my measure from the count of event to some aggregate value to better understand my consumption. So by doing this, you can see the data got filtered differently. So now let's see, I will choose different chart for me to better understanding. You can see this. Since I choose transformer weather as a dimension, you see we grouped entire meter network into different weather groups. I can see, okay, this is the highest weather, then they has the most significant power consumption. Let me add that one into the filter. So this is how you add the filter list. So by doing this, you filter out all other stuff. Then I will see, okay, one more thing here. You can also change this to 20 as a default return record to 200 or even 2000 based on the data item you have. I just use 20 here as a default. So now I know those area actually covers all the meters under this transformer weather between 94 and 96 degree. Now let me introduce another dimension. I like to see individual meter in this weather area that consumes my power the most. I will introduce the second dimension as a meter ID. Now I can see all the meters in this weather. This is how I like to understand my meter network performance. Of course, you can choose different graphic to demonstrate how your meter network, based on the filters, based on the variable importance you have identified from the solution. So pretty much the demonstration for now is completed. There are other many detailed features I don't think I have time to go through, but if I will be here after this demo in case you have any more questions. Okay.
Anyone who hasn't put their business card in here, you can win a free iPad, so it might be a good idea. You can pass it around, and I'm just going to summarize here. So a couple of things to finish off with, and then we'll, I think, have a few minutes for questions. As I said at the outset, and Hanlon had a chance to show some of this, it's the integration of 4 key components that makes our platform for IoT analytics special. We talked a little bit about that. Hanlon had a chance to show it. Does anyone want to pipe up and be known as the person who knows what the labels are that are associated with those 4? Or am I going to have to keep talking into the microphone? Anyone want to raise their hand and be smart? Any brave folks in the audience? I'll take that as a no. Let's go with thing definition is the lower left. That's incredibly important to any application in IoT, of course. Then you have to grab all the data is the second step in the picture. Analyzing it all and putting it in context is the third step, and visualizing it. It's really essential to understand that without those four integrated together, any IoT application that you're going to build for analytics is going to be incomplete. Those four are required. We think that's a special part of our platform. Last thing I want to talk about is an analytics value chain is a concept that's also key to our platform, and I want to make sure that we convey that to everyone. First and foremost, you have to have fast data ingestion. You have to do real-time streaming analytics. You need to put context around that data. That might take the form of the location or the physical environment. And you also have to be aware of the current situation. One of the things we did in today's demo is show the status of all the smart meters. That data is crucial to understanding what actions you might need to take. In today's demonstration, you can imagine we like to talk about a hot weather case where the demand is outstripping the supply for utility, and you're going to have to take action. We didn't have time here today, but the typical case would be spinning up a generator to react to that. That's a classic example from a utility where if you don't have the action triggered with the analytics, you're not going to be able to solve the instantaneous business problem. And so that's the crucial understanding with our platform. The metaphor I like to describe is, the doctor can analyze what's wrong, the doctor can prescribe what might be right, but all the values on the right side of that picture, where you have to take the intelligent action. And in the case of a utility that's doing smart meter, it means spinning up a generator. In the case of the medical metaphor, it's doing what the doctor tells you. But the net effect is all the value occurs with the action at the end. Action combined with analytics is what makes our platform special. That's essentially the summary. We hope people have questions and interest. We certainly will do the drawing for the iPad, but we'd love to take questions.
Let me do the second part too. Yeah. Since I think we still have some time, I'd like to demonstrate the second part. I didn't do after I finished the dashboard and a diagnostic part. So I like to say how we can build up a solution like what we just saw using simple 4 steps that Mike just mentioned, right? I think let's do this.
What is your company name?
Company name, Vitria. Yeah, okay. So this is what we have seen from the dashboard demo. How we can enable our business users to use our platform to build this solution. It's relatively easy. As you can see, we will go through the, hold on a sec. It's like, okay, so here's the steps how a user can build up a solution like this using our platform. Like Mike just mentioned, we have a 4-step workflow. First of all, you need to enable your thing definition. Our platform allows user to analyze anything at IoT context. It can be meter, it can be cell tower, it can be medical scanner, it can be anything you want us to analyze for you in the system. All you need to do is upload your sample data, so system will be intelligent enough to figure out the basic schema, then you can edit based on that. So after you define your scene definition, the second step is to inject the data using our data service. The data service can be deployed in 2 different models. If you have an in-house data engineering already cleaned up your data, then we have a set of data format we support, like CSV file, JSON file, XML file. You can upload directly for both your streaming data, telemetric data, and your reference data. Or if you need help from our PS team, we can actually help our client to clean up the data to make sure we can get the project back into the workflow. So from the data service is the place you get data inject into our platform. Then you get into our Pentempo analytics engine, where is how your user can define the KPIs, how you want judgment to be deployed, how you want your notification to be configured. So I click edit here because I already pre-configured everything. You will see all the KPIs I have configured here. Since I don't want to really save it, I click read only model. So this is you start with your KPI side, how you define it as a first step. Now after that, you go to your step 2, is to configure the data source. in case you upload multiple data sources, you need to know specific KPI that associate with specific telemetric data. And after you configure that, you also need to know whether there's specific reference data is associated with your KPI and how you define your KPI, right? KPI can be different categories. For example, it can be very basic measures we define as a basic KPI. The KPI can be composite KPI or a computed KPI. Based on different formulas, you can actually enable all of those. So this is the KPI you enable this, and after that, this is the dimensions you want the system to roll up with to do aggregation based on your reference data or your scene data. So this is judgment criteria, how you think your status is red, yellow, or green, and this is how you configure your notification. After you do that, you finished with your analytics service for most of business users. Then you get back to the workflow, then will be the data visualization service. How you get all those pre-built dashboard, how you get all those widgets. This is a very simple configuration you only need to do because everything is pre-built. Only thing you need to do is identify the default dimension you like us to display. In case this is a location-based, you can let us know where to find latitude and longitude information. The rest of those is all done automatically. So this is a workflow we introduced that allows business user to create analytics solution without data science or developer skill set.
Switch over to just that last page because I'm summarize. The last thing I have to say as part of the demo is that action is where all the value is in IoT analytics, not analysis. This picture summarizes what's most important to us. It's our intellectual framework for the platform, and we appreciate you coming to the demo today, and let's see who the winner is. Everyone get their card? Everyone get their card in? Okay. You want to be the announcer? Jim Landowski. You get your card back. Congratulations. Yeah, the two. Oh, no, it's the... Oh, okay. That's right. Thanks, everyone. We'll be hanging out. Vitria team members, raise your hand, because if people have questions, there's a bunch of us in the audience. I think I see a couple over there being shy. Anyway, we're all around. We'd love to talk to you if you have questions, but we have to make room for the next demonstration. Thank you.